Good news, everybody. I am joined today by Mr. Allan Jude from Clara Systems. We are going to talk about all things ZFS. We ran into each other at the 45 Drives Creator Summit, and that was a really interesting situation because we were at Cape Fear Community College demoing stuff for Cape Fear Community College students and Proxmox and Ceph and replication, and we were doing 100 gigabit networking without a switch, just using crossover cables. And I was also turning the 45 Drives folks onto SRIOV for GPU partitioning. And, we got together and said, hey, we should do a thing. And so this is that thing. Hello and welcome.
Yes, thanks for having me. Yeah, it was great to get to hang out with you for a couple days. We had done a couple of videos before, but I never actually got to meet you in person or actually get to hang out for a while and, chat over dinner and so on. So it was great.
Yeah, it's a lot of fun to share the war stories. It's like, oh, let me tell you about all the suffering in this context. Oh, but see, our suffering is your warning. You can learn vicariously through all of the stuff that we've had to endure in order that you don't make the same mistakes.
Yeah, or just other people's things that we've had to clean up. We did a great webinar last year for Halloween, just a bunch of horror stories of people who had pressed the wrong button or typed the wrong command and just made 200 terabytes of data disappear.
Oh yes, you actually have a lot of content that you guys have produced over the, you should tell everybody where to find that. And also like the Clara Systems stuff. I'm glad to see you putting more stuff out into the ether under the Clara Systems banner, of course, but that's not what I'm talking about. So like tell everybody where to find all that.
Yeah, so Clara's launched a new website called the ZFS Basecamp. So it's on clarasystems.com under content ZFS Basecamp. And it's kind of a step-by-step through getting to know ZFS. So it kind of breaks all of the content we have, whether that's, articles and webinars and videos and other content and white papers and case studies, all of that down by kind of where you are in your journey learning about ZFS. So if you're just like, I don't know what a VDEV is, then there's a whole set of articles about all the different VDEV types and how to decide if you want this type or that type and when to use them. And then there's other sections that go through like, all right, I already have ZFS, or I've decided I want to use ZFS, but how do I set it up right? And then it's like, all right, I have ZFS, but how do I maintain it and keep it working? And then how do I do my backups and all the different kind of steps in a journey of going from I've heard of ZFS, I want to use ZFS, I am using ZFS, what do I do when it goes wrong, and how do I make sure it doesn't go wrong?
It is very awesome to see the hardware and software coming together so that there's the historically it's like, oh, the overhead of ZFS, or it's like, oh, ZFS is not appropriate for all scenarios. It is very nice to see that the window of situations where ZFS is appropriate is getting larger and larger and larger, and the performance overhead is getting to be less and less and less. There have been a lot of improvements the
Yeah.
last year for NVMe performance. It's been great to see that, and also lower overhead with replication and sync.
Yeah, a lot of stuff happening there, and just all the pieces kind of coming together. And kind of as we talked about a bit at the 45 drives thing, the software kind of catching up to the hardware. NVMe kind of stood everything on its head, where everything we knew about hard drives isn't true anymore. The sector sizes aren't always just 512 bytes, and now they're not even just always 4K. They can be even more. And then, you know, an NVMe drive can do more than one thing at once, whereas a hard drive or even like a SATA SSD, you can queue multiple things to it and it can decide what order to do them in, but it only really completes one thing at a time. Whereas an NVMe maybe completes 63 things at a time. And then, suddenly the whole way you build this out is very different. And like the way you have to think about how do you aggregate IOs together and how do you decide when to do a flush, and all the different parts really get a lot more complicated when suddenly you're doing 63 things at a time.
Yeah, sometimes the overhead of doing the most efficient thing possible is not as efficient as just sending the data. Just send it.
Yes, just doing the fastest thing possible might actually be more efficient in this case. But how to do that in ZFS without losing the advantage that on a hard drive, spending a little bit of CPU time to aggregate things together and reorder it could still give you a huge performance benefit. So you don't want to throw it all out either. And getting those just right is quite interesting. But also the way the NVMEs fail is different. And so improving things there as well.
So I think one of the first my gut. I don't know if this is still true or not. Here we get it. It's like this on today's episode of Wendell embarrasses himself. My first go to for somebody getting started in ZFS. One of the first things to understand is like I'm the psyche here is a home lab
Mhm.
aficionado. It's like a tinkerer. They know enough to be dangerous. They probably got some kind of like a rack mount system or two, or some an old computer or two running at home, and they're experimenting with probably a lot of mechanical hard drives. Probably not a lot of enterprise flash yet. Although I try to alert our forum whenever I see good deals on enterprise flash, which is
Yep.
weird in the current global climate that we're in right now. Like it's dried
Yeah.
up a little bit. Um, but one of the first things to really like you should spend some effort understanding is um, right amplification, but in the context of what are you using your storage for? Because there are crazy randos on our forum that have 90 drive wide VDEVs and they only use that for media. And it's basically a write once, write only, and it's not terrible. The performance is actually
No.
okay.
Yeah.
So,
You
you
know,
know,
when your blocks are big, then hard drives can do really good. You know, we've built arrays of hard drives that can do, tens of gigabytes per second, no problem. Because if every read you're doing is big enough, then you're not seeking all over the place. It's just nice, big, chunky linear reads, and you can get the 200, 250 megabytes a second that the hard drive can do physically. And, you do that times 24 drives, and you have a lot of gigabytes per second all of a sudden, right?
the common thing that I see folks falling into, and part of what that I gave all that lead into to the kind of question or to kind of like what's the quickest way to red pill somebody on everything they need to know for like choosing the right variables for the volume, setting the right sector size, minimizing right amplification if that's a thing. Because what I see on the forum time and time again is folks that see the 90 wide VDEV success stories and the 1 megabyte record size success stories, and then they set up their virtual machine pool for that. And
Yeah.
then it's like, oh, I was doing some web dev on it, and I was copying around all these 60 kilobyte files, and I'm only getting like 200 kilobytes per second I/O to my virtual machine, and it's like, oh, what's going on under there? So what's the 10,000 foot view, and then like you have some really amazing resources to explain all of that, and it's like no, you could it's like you could look at the workload and you could say this is what it's doing, and then just set your record size there, and ZFS will let you do that on the fly even.
Exactly. So, there's some kind of general guidance we give for like databases. You really got to be specific. So you want to set the record size to match the page size of the database. So for Postgres, that's usually 8 kilobytes, and like MySQL type things are 16 kilobytes, and so on. Um, Although there are some caveats to that, and we can touch on in a minute. In general, for VMs, I recommend 32K or maybe 16 if write amplification is your biggest concern. But basically, if the workload inside the VM is highly random, then going to the slightly smaller sector size, it trades off some efficiency on the metadata and so on, but it will, reduce that write amplification and mean that you're not doing twice as much work for no reason. Uh, to quickly explain write amplification, that is, if we're using a larger record size, say 32 kilobytes, and you want to change just one 4K of that 32 kilobytes, ZFS has to read the whole 32 kilobytes, calculate the checksum, make sure that it read properly. In memory, modify one particular 4 kilobytes of that 32 kilobytes that you changed, calculate the new checksum, and write that out to disk. And so, in order to write 4K, you just read 32K and wrote 32K, making the drive do a lot of extra work. Versus if your record size was just 4K, it would have not done any reads and just done one 4K write.
Yeah, and
And so that can very quickly make your hard drives too busy, right? The hard drive can only do about 200 IOPS each. And so, if you have each VDEV is kind of all the drives work in lockstep. So you only have the IOPS of one drive per VDEV. So if you have a 90 wide VDEV of hard drives, it can only do 200 IOPS, period. And you can very quickly run out of performance. And like you said, get terrible performance for your 1,000 tiny JavaScript file workload.
but it's totally okay if you've got 200 people streaming media from your vast library because It's not, it's dealing with 1 meg record sizes. So,
Yeah,
but
and exactly.
there's another piece of wisdom that I've been guilty, not wisdom. There's another terrible kludge that I've been guilty of foisting upon users, and that is for those data sets, especially in like a home lab scenario where it's like I'm running a bunch of VMs, but it's like Pi-hole and stuff like that. And there's not really a ton of changes happening on those. But sometimes when there's an update or something, I just want it to go fast. And so conventional wisdom and terrible thing idiot does is disable sync and then set the amount of time that data can be in flight to like 2 minutes, because then I don't have to do quite as much work. There's that. Oh, and the other thing that is so like 4K sector sizes. There's also the thing to understand about what the operating system is doing, because like if you're running a
Mhm.
Windows VM, say, and the volume is large enough, it will actually be dealing with 32 kilobytes at a time or 64 kilobytes at a time at the file system level, and that can also align really well with ZFS. And so there's less of a write amplification issue. Like you can claw
Yeah.
back some performance by not. So that's another thing to kind of keep in mind.
Yeah, so looking at that second one first, if you run just check disk on Windows without the don't tell it to repair or anything, and just the very short one it does, and it'll tell you information about the this cluster size that it's using. And then if you can if you know what that's going to be, then if you have the ZFS that's backing it be that same size, then you won't get any amplification. And the other advantage, as you said, like if it's using 32K, and the reason why I recommend 32K over like 4K is that ZFS's compression gets to compress each record together. So if you have 32K and you compress it and you get at least 4K of savings, then that's going to save a bunch of space. But if you set the record size to be one sector, then ZFS won't even try to compress it because it can't save a whole sector, right? It can't compress something to 0% of its original size. Um, and so, unless it's literally all zeros, but that's a special case. And so, that slightly bigger size can have multiple benefits. On top of, compressing it, if you have 32K at a time, you might compress it down to 12K or something and have a lot more savings than if you compressed it, each 8K separately, you wouldn't get as much savings because if you don't save a whole sector, then it doesn't compress at all. But the other advantage of that of just saving space is also the cache. So ZFS's cache is more advanced than what you get with like the normal buffer cache for like ext4 or something on Linux. It caches the compressed version of the block and then just decompresses it as you need it. And it has a separate subcache of the blocks you're decompressing multiple times a second to avoid overhead. But it means that if you compress your 10 gig VM down to 7 gigs, then it means you could keep all of that in cache a lot better. And so the blocks that are hot across all your VMs, if they're taking only 70% of the original size, then you can cache, 30% more data in your RAM and get that much more performance out of the system. And to the same effect on the hard drive, right? If your hard drive tops out at 200 megabytes a second, if you compress everything and save 30% of the space, you can actually write 30% more to the drive because, each block is actually taking less space because it's compressed.
Now, there's a lot of people in the audience that their teeth are on edge. I can feel them. It's like I've made some mistakes in what I have done. What is the fastest way to fix this? And what I would do is it's like ZFS datasets are a great sort of rescue thing
Yep.
here. It's like, oh, you've made an oops, no problem. Just create a new dataset, set the record size on the dataset, and just move the hard drive of your VM. Just turn your VM off and just move the data set that it's on. And ZFS moving from one data set to another will issue all those corrections for those past transgressions that you might have made with compression on or off, or A
Exactly.
time, or
Any
record
well,
size or whatever.
A time's a nice one because you can change that one after the fact. But the
Okay.
record size, yeah, once the file's created, the record size is set in stone. So yeah, just make a new data set and move the file over. One caveat on newer versions of ZFS, there's a feature called BRT or the block reference tree, which is basically ref copies. And it actually allows you to copy files between data sets without duplicating the data.
Ah.
But it means it sticks to the original sector size, which or record size, which might be what you want. So you might, if you're just using like CP or something to move that file, from the old data set to the new one, you might have to specifically set, ref links equals none, so that it does a hard copy instead of just cloning the file. Uh,
That is
it's a
hard-won
big
knowledge right
advantage.
there, chat. Listen, wisdom.
Yeah, it's a big advantage to be able to say, I just want a second copy of this VM where all the blocks are shared, and only if we change something will it take more space.
Yeah,
Being
that
able
sounds
to
like free
basically
compression.
clone a file instead of cloning a whole data set. Although a separate data set for each VM gives you a lot more flexibility, and if you can manage it, that's actually better. But if you can't, yeah, this ref copy is really nice and can really speed things up. Clara even integrated support for it into Samba. So if you're using Windows file sharing and you copy a file, from and to the same Samba server, it can just clone it and not use any extra space and do all the copying on the server side instead of, copying it over the network to your machine just to copy it back to the server.
Now that is awesome because uh, a lifetime ago, I wrote a shell script to map shadow copies onto ZFS things, and that was before VFS objects was even a thing. And then
Mhm.
somebody was like, "That's a good idea. We should do that for real." And then, and then, and then the rest is history. And so it is
Yeah.
very nice to see that those kinds of things that are integrated. We should remember to talk also about deduplication because I think
Yes.
deduplication is a lot more accessible in a lot more scenarios now, like to the nth degree.
Yeah. So I guess it was last year, the folks at TrueNAS sponsored Clara to build fast dedupe, which was implementing all the ideas we had about how to make dedupe better. The way dedupe works in general is every time you create a new block, ZFS calculates the hash because it was going to do that anyway, the checksum. But when dedupe is on, we keep all the checksums we've ever seen before and how many times that checksum has been used. And so this way, if you write a block that's been written before, say installing the same update in multiple VMs or whatever, it will say, oh, I've seen that hash before. I can just say, instead of writing that to disk, I just make it point to the existing copy and update the number of copies in that list so that we know not to erase that block until every copy of it is no longer in use. The problem with it was the way ZFS did it was it would update that giant list each transaction group, so like every 5 seconds. And because it uses a strong checksum like SHA-256 for dedupe, it means if you write 10 blocks, they are almost always like perfectly randomly distributed in what the checksums are going to be. So, if you write 20 blocks, only 2 of them probably are ever going to have the same first 2 letters of the checksum. And, the checksum is like 80 characters long or whatever in hex. And so that means in that giant list, it had to update, 20 different chunks of that list. And that meant, reading the old copy, making the change, writing it out, and then updating all the blocks that point to that block. And it was just a lot of work for ZFS to do every transaction group just because you birthed a couple of new blocks. So what we did at Clara is we used this kind of a write-ahead log kind of logging concept where instead of updating the list in real time, when you birth new blocks, we just write changes to a log file saying, this checksum went up by 2, this checksum went down by 1. And then once that log gets a bit bigger or the system is idle, we'll rotate and start a new log, take the old log, sort it alphabetically by the checksum, and then update the table with all the checksums that start with 000, and then all the checksums that start with 001, and so on, so that we're amortizing the cost of updating the list and all the indirect pointers for it, and it makes the performance penalty significantly less.
It gives me an
Um,
idea. I should put a calculator on the website that is like based on the size of your pool and the record size that you have. What is the maximum possible size of your dedupe
with the
table?
dedupe table, yeah. So what we did was then added the dedupe prune feature, which walks through that dedupe table and finds blocks that have been added, have never had a second copy found, and are getting older. So when we built fast dedupe, we changed the way the dedupe table works to make it smaller so that you could fit more data in less overhead. But also we added a timestamp to it. So now we know, all right, you wrote this block, 2 months ago, and in that time, no second block with the same checksum has been seen. So it's not very likely that in the next month, another one of those is going to show up. Whereas you're writing a new block right now, it has a much higher chance that, 2 minutes from now, you're going to write a similar block again.
Is there any hard and fast wisdom on dedupe sizing? I know in the past I was like, oh, you're going to need a lot of memory, but it sounds like you could get away with it now. It's like, oh, I've got 20 terabytes of spinning Rust and 16 gigabytes of memory, and it's like, that's not unreasonable.
Yeah, basically with the quota, you can decide how much you want to dedicate to it. So, if you're sizing your arc to half your RAM, then I wouldn't make the dedupe table more than half the arc. But, at that case, now you can have a 4 gigabyte dedupe table. And especially if your record size is big, like those 1 megabyte blocks, then each 1 megabyte block's only one entry in the dedupe table. Although if you make that same data, but at 128K records, then it's going to take 8 entries. And if you make it at, 4K, then you're looking at, 1,000 entries or whatever. It gets kind of out of hand really quick. The problem with going to a really large record size in dedupe is that the whole 1 megabyte has to be exactly the same. So sometimes a smaller record size will find more bits that dedupe where, the second 16K of these blocks is the same, but the third isn't.
Yeah.
And so it's always a bit of a trade-off there. But most of the time, compression will get you most of the way, and dedupe doesn't necessarily make sense. But at least now, there's not this huge risk in testing it, because if you set a quota that's reasonable, you're not going to be in the situation where like, oh, we can't import your pool because we can't fit the dedupe table in RAM, and paging it back and forth is going to take so long. This pool will take a month to import.
That makes sense. The in terms of like catastrophic error, and you've lost, like, say that you set up say an NVMe mirror for your dedupe table, and then you catastrophically lose the NVMe. Are there tools to reconstruct it? Is that a bad situation?
So it used to be, one of the other things is the dedupe table used to be stored in triplicate. And now that we made it safe, if there is some corruption, we got that down to just one copy, which also cuts down the amount of overhead a lot. Like when we were talking about that previous example with the 8 kilobyte sectors and like 600 gigs of data, one of the other big things LogDedupe did on top of only storing each update once is because you weren't updating all those indirect blocks every transaction group, it cut the amount of extra writes that went just to the dedupe table from like 3x the amount of data you were writing to like 10%. So it went from literally writing like 1.2 terabytes to writing like 50 gigabytes
That's a
to
big difference.
fill up the data. Yeah, it was a huge difference. The chart looks ridiculous on my talk for the ZFS Dev Summit last year about it.
That does sound really, really exciting. And is this pool wide or is this data set wide? Like, can I put my toe in the water with dedupe in a data set, or do I need?
So dedupe is pool wide, but you can turn it on and off per data set.
Okay.
So you can say, I know this data set is going to have some deduplicate stuff, and I don't want it for the rest of the pool, or turn it on for the whole pool, but I know this stuff over here is not, it's video, so it's not going to have any duplicate blocks in it, so don't bother filling up the list and using up that limited amount of RAM that we're going to store that list in on blocks I know will not dedupe. Nice. So you can be very selective.
So this is definitely like the small office, home office, home lab use case, and this unlocks a lot of possibilities for folks that are running. It's not uncommon that we will have setups where there's 2 or 3 Z pools in a system. Like there's spinning Rust and NVMe, or spinning Rust and SATA SSDs, and they're not mixed together, except maybe for like special devices, the metadata special device. I have metadata special device on my spinning Rust pool, and that is a
makes
game
a
changer.
Huge difference. I think the biggest thing is, like, you consider the average seek time is about 4 or 5 milliseconds on a hard drive. So if you want to read a random block of a random file, even if it's just like scrubbing through a video, ZFS has to read the indirect block to find out, which file is it? And then, okay, this file is really big, so it's this whole tree of blocks. So I have to walk down each step in the tree, and that tells me where the block that tells me where the next block is. So to know where on the hard drive the 4th megabyte of this video is, I have to walk through where's the whole file, and then there's a block that describes the first 10 gigabytes of it, and then a file that describes like the first 128 megs of it, and then a block that describes where each 128K of that file is. And so in total, if I have to read 5 blocks in order to read that one little bit of the file, in total, that's going to take 20 milliseconds. Eventually, if I'm reading the same file, ZFS will cache a bunch of those top level ones and it'll be faster. But if we're completely cold, we have to do five millisecond steps to read one block of that file. If we stored the metadata, just those indirect blocks, on a mirrored pair of SSDs or an NVMe or whatever, suddenly that cold random read, instead of 25 milliseconds, takes 5.5 milliseconds.
I notice.
Because the first 4 steps are, less, are fractions of a millisecond, and then you have the one seek on the hard drive.
But it is not unreasonable these days, IMHO, to run metadata special device with normal, relatively higher grade, look for an NVMe that gives you high endurance, or that is like, one drive write per day. And it doesn't seem like you're going to run into issues, even when you've got
Yeah,
a
because
relatively busy pool.
they're only going to last so long, even without the right endurance. But yeah, to your point, a high drive writes per day is good. But the other thing is, like, if you're that worried about endurance, just buy a bigger drive.
Yeah.
Because the wear leveling will have more cells to balance through, and you will get more endurance. And unless your pool gets really big, you're probably not going to fill the metadata VDEV anyway. Although, if you set the setting where you say any files that are really small, store them as metadata instead of on the hard drives, you can very quickly fill up that special VDEV. And
Yeah.
the problem there is you can't undo that, right? If a file is stored on the special VDEV, other than erasing it and rewriting it as a new file, it's going to stay on that special VDEV. And if you fill it up, then there's no room for more metadata, and suddenly your giant performance win is gone away again, because, well, you have the win for all the blocks you wrote before until the device was full, but now that it's full, any new writes don't go there anymore.
I was going to say that they're really ramping production, and Flash is finally going to be affordable, and we're going to see the end of spinning Rust. But the demand is so insatiable in the enterprise now that spinning Rust is going to be around for a while longer.
A lot of times especially with the really large NVMe, we see a lot of trade-offs. So like, we see 120 terabyte NVMe drives. There's some legitimate ones from like Solidigm and Kioxia and so on, but a lot of the kind of lower endurance ones that are just focused on the size have a lot of trade-offs, including usually a much larger sector size, like 32 kilobyte sector size, or even 128 kilobyte sectors. And that is because the flash translation layer that the SSD has internally works kind of like dedupe, in that if you have bigger sectors, then we need to keep fewer entries in the table to say, oh, this offset is actually on this piece of flash, and that offset is on this other piece of flash, and being able to change those when you do wear leveling. But in order for the NVMe to perform, that has to be in DRAM, in addition to being synced out to flash to be power loss safe. But if you're going to have 120 terabyte NVMe, that's a lot of RAM if you're going to keep an entry for every 4K sector. So like, well, if we make it 128K sector, we need like 16 times less RAM in the per device, and that makes it much closer to getting towards competing with hard drives on price. But now you're dealing with, write amplification happening under the hood because the NVMe is emulating the 4K size, or ZFS actually seeing that the drive's 128K and trying to do its best to accommodate that. And then somebody has a ZVol with a record size of 16K, and every time they write 16K, we pad it out to a whole 128K sector. And then their pool fills up and they're like, where'd all my space go? My ZVol is only 10 terabytes, but it's taking, 100 terabytes of space. That doesn't make any sense.
This is a problem for linear algebra as well. And the math libraries have solved that by putting a bunch of micro benchmarks at the beginning of their stuff when they're compiling it. And it's like, all right, you're based on your system, this is how we're going to do linear algebra, because we didn't know which CPU instructions would actually be the most efficient under the instruction set, particular generation, thermal and power characteristics of your system. We're just going to run a test and see how it does. And then it's like, oh, it's this. This is fine.
Yeah,
We're headed there for storage.
ZFS does that itself for, I think, like 6 different things I can think of. So like which version of SHA-256 is going to be faster on your system? Is it, this plain one, or like the neon accelerated one for ARM, or, the SSE 5.4 version or the AVX 512 version, and it tries all the different ones, and it kind of does this micro benchmark when you load the ZFS module and probes your CPU and say, all right, try every one of these algorithms, and whichever one does it fastest is the one we're going to use. And it does the same thing for like the RAID Z calculations, and even sometimes I think part of the Z standard compression also kind of tweaks itself based on, this is what's fastest on your CPU versus, someone else's will be very different.
That's another situation where it's like I've created this pool on this one system and I've imported it on the new system, and all I did was just copy stuff from one pool or from one data set to another, and now it's mysteriously faster. And it's like, yeah, when it rewrote it the new better way, which not just that, but
Yes,
also like new pool, new ZFS version number,
it's
also
defragmented because we wrote it
yeah,
all linearly. Yeah, exactly.
yeah,
Nice and
yeah.
fresh.
And this is
Uh,
important for the folks watching that have, it's like there are folks out there that have a 10-year-old data set, and it's like, you can just, instead of adding on hard drives and you probably should create a new pool and copy some stuff over
yeah,
to the
and
new,
just
like that's a good idea.
ZFS send it over, or if you want to rewrite it to get new record sizes and so on, then yes, copy. But if it's easier to just use ZFS replication because it also means you can do it while you're still changing stuff. So you take a snapshot, replicate it. That takes a couple of days, depending on how many hundreds of terabytes of data you might have. Then you take another snapshot and send only the differences, and just repeat that until your time delta is down to like a minute, and then you can stop the world, do the last minute's changes, and then swap over your new pool, and you're up and running again, and everything is new and shiny.
Now, that's how I did the migration for Steve at Gamers Nexus, was just ZFS send and receive. And I actually just used
Yep.
mbuffer to try to make
Yep.
it go as fast as possible because SSH was too slow.
Yeah.
But I've also messed around a lot with Sanoid and Syncoid, which might not be on everybody's radar. And syncing and replication was also an important part of the 45 drives stuff, because it's like, oh, you can build a cluster and you could use Ceph, and it's like, well, for a couple of machines, I don't know. And then there's also BGFS, so like, introduces to the world of sending and receiving and replication and backups, because send and
Yeah.
receive for backups is like the best thing ever.
It is literally the best thing ever. So the biggest thing with ZFS is you want to do your backups, whether they're with replication or with a regular backup tool, from snapshots. Because if you take a snapshot, it's going to be every file on your whole pool at that one instant. And so when you back it up, it's every one of those files unchanged. Whereas if you do a traditional backup on a running system, then the first file you back up is from midnight, and the last file you back up is from like 6 hours later, and who knows how much has changed in between there, let alone the problem of files changing while you're backing them up. And so that leakage is very consistent, but it also means if you're looking at whether it's your home lab or a small production cluster or whatever, if you have your VMs running, being able to snapshot the storage and replicate it, every 10 or 15 minutes means that you have all the data on a second system. If this one catches fire or the hard drives die or whatever, all the data is right there up to only a couple of minutes ago. And it's not in a backup that you have to restore. It's in a ZFS pool that you can fire up your VMs from immediately.
Yeah,
Right? If you're backing up your KVM config from Proxmox or whatever manager you're using, then you can get back up and running right away with a version of the VM from at most 10 minutes ago.
I never used Sanoid and Syncoid for that, but I was surprised at how easy it was. So easy to set it up. I really thought I was going to accidentally destroy something important.
Yeah, it's really designed for that use case. Some of the people behind Sanoid and Syncoid literally use it to replicate VMs to an offsite back. Like they have the primary server that's running the VM, a second server on site that is ready to take over at a moment's notice, and replication to an offsite that's only done 4 times a day or something, so that if a whole building burns down, they still have all the data.
Yeah, I think that's what Sanoid and Syncoid do. But
Yeah.
also, if you're using Proxmox, this is basically built into the GUI now. Like you can just set up the
Yep.
replication options, and it's like, oh, this is stored on a ZFS dataset. It does the right thing, which is impressive.
Yeah. Uh, and yeah, like you're saying, Ceph can be really nice, but if you don't have 7 machines, it's not a great candidate for Ceph. And then, it's also just Ceph scales really well. You can keep adding more and more machines, but it doesn't scale down as well. And especially if you only have a few machines, the performance penalty of having to wait for that block to be written out to multiple machines before you can, finish that write, can really hamper the performance of your setup. Whereas, ZFS writing to NVMe and having its redundancy all inside the machine, not having to go over the network, can really speed things up. And then you use ZFS replication to asynchronously keep that copy on a second machine that's, only a couple of minutes behind.
Yeah, people don't think creatively about these kinds of problems. Or data, like even MariaDB. It's like I would let's set up an HA cluster of MariaDB, and then you don't need to do any replication at all. It does its own,
Exactly.
and that's faster and better and more reliable.
And it knows what's happening in the database better than ZFS, which is just dealing with the blocks. And so, yeah, a lot of times, if your workload is that sensitive, the HA should be like at the application layer, not at the VM layer anyway.
Yeah.
And then you eliminate this whole problem, and then you can get all that extra performance by using local storage instead.
That's a thing? You can do that? It's like, yes, we must teach you. And this is why doing this kind of thing in a home lab, even with relatively inexpensive machines, is amazing for upping your own skill set and doing that kind of thing. We have like the Forbidden Router series, and people are like, no, you don't want your router to be a virtual machine. It's like, you get good at high availability when it is.
Yeah, and it's like, the ultimate cheat code at the VMs. Like, when I was in school, we didn't have that. The part of the reason why I went to this school was they had a lab with 50 computers and a dozen routers that I could actually play with all this stuff. Now it's like you can build that whole lab inside your laptop and go to town.
Well, do you have any other thoughts or advice or things that you notice people tripping over and over and over again?
Not so much that right off the top of my head, but the other exciting thing going on right now is we're working with the folks from HexOS on AnyRAID.
Oh, yes.
Which is,
this is
the
really
most
exciting.
requested feature in ZFS of what if I have a couple of different size hard drives and I want to make a RAID Z out of them and get, more than the lowest common denominator of space. So AnyRAID basically breaks up the disks into these little tiles and does a better algorithm, a packing algorithm, to find the best way to distribute those across a bunch of the drives to get more usable space out of the same drives, and really maximize that.
But with the same level of fault tolerance.
Yeah, and you can select RAID Z 1, 2, or 3 and get that same fault tolerance. It's just the width of the RAID Z won't be as wide as the number of hard drives you have, because it's going to make up bigger virtual drives by spreading the blocks across the existing drives. But combine that with the ability to add one drive at a time as you need them, can really give you a lot of advantage, and the flexibility that people have always complained ZFS doesn't have, because it was designed for enterprise where you were going to, never need less storage and always be able to add more storage, like 8 drives at a time, not 1 at a time.
It's very nice to see a lot of movement in development in ZFS and all of these things, which benefit not just the enterprise, but also us, the plebs down at the bottom. It's nice.
Yeah, like AnyRAID is very specifically targeted at the home lab people. Like, that's not really a feature anybody in enterprise had been looking for, and that's why it didn't exist in ZFS yet.
Awesome. Well, this has been an amazing chat.
Yes.
Any other parting words of wisdom?
Just keep using ZFS. Don't be scared off by it. We have all the resources out there now with the Basecamp on how to get started with it and get comfortable with it. But yeah, home lab it up. That's the best way to learn anything.
It is literally faster than it has ever been. I think probably by an order of magnitude over the last decade.
Yeah.
I mean, it has come a long way, and that is really, really exciting. So, Allan Jude, Clara Systems, check out the links below, or hit me up on the forum. There's a forum thread to go with this, I'm sure, and we've got all kinds of other forum threads about various other ZFS adventures. But it's been great having you. Hopefully, we can do another chat like this. Be sure to check out your other podcasts and everything else. It'll be really amazing.
Oh, yes. 2.5 Admins is my weekly sysadmin podcast, if you are interested in other stuff, and we also answer questions about ZFS every week.